For the function hxy equal to the root of x squared plus y to the fourth, let's find the direction and rate of steepest descent at the point 1, 1. So first, I'll write my hxy, slightly different form. So let's write this as, let's say x squared plus y to the fourth to the 1/2 power. And now we can treat this as a power rule coupled with the chain rule. So next, if I want to find the gradient of h, let's say all xy, I'll write this as the vector 1/2 x squared plus y to the fourth to the 1/2 minus 1, or minus 1/2, times the derivative of the inner with respect to x pulls out a 2x. And now if I take the partial with respect to y, I get 1/2 the argument to the negative 1/2 times the partial with respect to y, which gives me 4y cubed. So let's go ahead and simplify the gradient of h at all xy. And I could write this as, let's say, x over the root of x squared plus y to the fourth, comma, here I have a 2y cubed over the root of x squared plus y to the fourth. And if I calculate the gradient of h at my point, 1, 1, everywhere I see an x, I'll plug in a 1. When I see a y, I'll plug in a 1. This will give me 1 over, this becomes root 2, comma, 2 times 1, or 2 over, and again, 1 plus 1 is 2, another root 2. Okay. And so now I want to find the direction and rate of steepest descent. Now remember, the gradient will point us in the direction of maximum ascent. Okay. So for the rate of maximum descent, I'll simply take the negative of the magnitude of the gradient at my point 1, 1. And if I take the magnitude of the gradient, I get the negative of the root of the sum of the squares of my two terms. So this gives me 1 over root 2 squared plus 2 over root 2 squared. And that simplifies to 1/2 and 4/2. So I have the negative of the root of 1/2 plus the 2 squared is 4, root 2 is 2, so I get plus 4 over 2, or 2. All right, which I could write as the negative of, let's see if this is 4/2, it gives me what? The root of 5/2. And we can just leave that like that. And the direction of max descent, or steepest descent, is simply going to be the gradient of h divided by the negative of its magnitude. So I get the negative of the gradient h at 1, 1. Same at 1, 1. Okay. So I'll just write 1 over root 2, 2 over root 2. Put the negative up top and divide it by root 5 over 2. And if we want, we can simplify a little bit. And let's say I'll multiply the top inside this vector by the constant root 2 over 5. All right, so I could take the negative of root 2, let's say, over root 5 times 1 over root 2, comma, root 2 over root 5 times 2 over root 2. And you can see now if I cancel terms, I'm left with the vector negative 1 over root 5, comma, negative 2 over root 5. So continuing from the previous problem, we want to now find the directional derivative of that same hxy at 1, 1 in the direction of the vector v, which has direction numbers -3, 4. Okay, so now we know the gradient already. We know that the gradient of h at 1, 1 is the vector 1 over root 2, 2 over root 2. And so now to find the directional derivative, you may recall that the directional derivative of our function and the direction of some unit vector is just going to be the gradient of h at our point dotted with the unit vector in the direction we wish to go into. And so now we want to travel in the direction v, which is, I'll write as -3, 4, and the unit vector headed in that direction, because you'll see that the magnitude of this guy is larger than 1, of course. So our unit vector simply becomes -3, 4 divided by the magnitude of -3, 4. And of course, this was chosen because 3 and 4 will give us the Pythagorean identity 5, or 3, 4, 5 triangle. So I get a -3, 4 over 5, which I can write my unit vector as -3/5, comma, 4/5. So, and I'm sure we all recall the Pythagorean triple 3, 4, 5 for right triangles. And we know the gradient of h at our point 1, 1. So now to find the directional derivative, we're simply going to take the component of the gradient in the direction of u, which again is just a unit vector for vector v. So I'll now dot 1 over root 2, 2 over root 2 with -3/5, 4/5. And I'll find that the derivative of h in the direction of u, if I keep like components, my I dot I gives me 1, and my j dot j components gives me 1. And remember, I and j project 0 onto each other, as does j dot I. So I'll write this as -3 over 5 root 2 plus 4 times 2 is 8 over 5 root 2. And if I combine my terms, I get that the direction derivative of h in the direction of u is going to be 8 minus 3, or 5 over 5 root 2, or if I simplify, I just get 1 over root 2. And remember, it's a derivative, so it's just telling me basically my rate of change if I head off in that direction, -3, 4. Thank you.